Okay, we are going to do the bubble lab. Concept one is that membranes are fluid. So in this lab, this straw frame is going to represent just a section of our cell membrane. And we have a bubble solution that's going to be the fatty plasma membrane. Here is my plasma membrane. You should be able to see, whoops, it popped, that it is flexible because it is a plasma membrane made of fat. It's also easy to see if I put this little piece of paper in here. You should be able to see that paper floating around. So membranes are fluid, and those protein channels that are in that cell membrane actually kind of swim around. It got stuck. Okay, concept two is membranes allow for transport. So items that are really tiny can get through our membrane. And the way that they do that is they have to match the membrane. So if I take a plain old toothpick, so here's my membrane, if I try to put it through, it pops it. I don't have a membrane anymore. But if my toothpick matches the membrane, so remember this membrane's made out of fat. If I cover my toothpick in that fat, which is my bubble solution, it will slide right through. It doesn't hurt the membrane. So that's the first type of transport. Second type of transport, so there's my membrane, is when we use a doorway. So if you have something big, so I'm going to try to stick through this fat straw, or something that doesn't match the fatty layer. So if it's not a non-polar molecule, so if this is charged or if it's big, it won't slip right through the membrane, and my membrane just popped. But what it has to do is it has to go through that transport protein. So items that are bigger or charged have to go through that doorway. That's okay. Transport number three is how do really big things get across the membrane. Really big, so we're going to make this straw nice and fat. If I had to get something really big through here, we know that tiny things can slide right through. Molecules that are a little bit bigger can go through those protein doors. But if something's really big, your membrane actually makes a hole in it, and then huge things can go right through that hole. And this popped, but it would work. You just have to trust me. That's the third type of transport. Things can leave the cell through those big openings. They can leave the cell through the protein door also, and they can leave the cell by sliding right through. So it does go both ways. Concept number three is that cells do self-repair. So even if I put something really big through this membrane, so there's the membrane, I can put my hand in there and pull it out. It didn't work, but it will self-repair. So if I have this membrane, I can stick my finger through, pull my finger out, but the membrane fixes itself because those lipids are also attracted to each other. So big things can bust through the cell and the cell can repair itself. Number four is that cells divide by binary fission. So here's one big cell, and if I, what, disappeared, hang on. All right, there's my one big cell, and I can break it in half, and it divides into two cells. And again, because that cell membrane is attracted to itself, I just made two cells out of one, and that membrane refuses back together.